How do dimensionality reduction techniques compress data in ML? Imagine trying to fit a huge jigsaw puzzle into a small box. You need to find a way to keep the main picture intact while making it smaller. That's what dimensionality reduction does for data in machine learning. It takes a dataset with many features or measurements and simplifies it into fewer, more manageable parts. This process helps models run faster and makes it easier to see patterns. When working with lots of data, like images or text, having too many features can slow things down or cause errors. Dimensionality reduction helps by cutting down the number of features, but it still keeps the important information. Think of it like summarizing a long story into a few key points without losing the main idea. There are two main ways to do this. The first is feature selection. This method picks out the most relevant features from the original data. For example, if you're analyzing customer data, you might choose age, income, and purchase history as the most important. The other features, like favorite color or shoe size, might be less useful and can be left out. Feature selection uses statistical tools or model performance to decide which features matter most. The second way is feature extraction. Instead of just choosing features, this method combines or transforms them into new, simpler features. One popular technique is called principal component analysis. It finds new variables, called principal components, that explain the most variation in the data. These components are uncorrelated and capture the main patterns. Another method is autoencoders, which are neural networks that learn to compress data into smaller representations and then reconstruct it. They're especially good at capturing complex, nonlinear relationships. The magic happens because these techniques reduce the number of variables needed to describe the data well. For example, principal component analysis decomposes the data into components ranked by how much variation they explain. Picking only the top few components keeps the core information while discarding noise. Autoencoders learn efficient encodings that focus on the most important features, making data easier for machine learning models to process. In real-world applications, dimensionality reduction helps improve model performance by removing irrelevant details and reducing noise. It cuts down on computational costs, which means faster training and prediction times. It also helps prevent overfitting, where a model learns the noise instead of the true pattern. Plus, it makes visualizing data easier, especially in 2 or 3 dimensions. In artificial intelligence and machine learning, especially with large datasets like images or text, these techniques are vital. Tools like ChatGPT, DALL-E, and Midjourney relying on compressed data to generate text and images efficiently. When you use productivity plugins that involve AI, they also benefit from dimensionality reduction by processing data more quickly and accurately. It's important to remember that applying these methods ethically is key. If too much information is lost during compression, it could lead to biased or unfair results. Being transparent about how data is reduced and which features are kept helps ensure responsible use of AI. So, in short, dimensionality reduction techniques act like smart filters, keeping the essence of data while making it simpler and faster for machine learning models to work with.